All right, people, check it out. Those of you on the packet. Woo, last page. All right, this is the end. Quick tear. Okay, so conditional probability. We talked simple probability before. We talked about dependent versus independent events. Now what we're going to look at is what's called conditional probability, which means the probability an event is going to occur given, that's going to be the magic word today, given that another event has already occurred, okay? For the time being, I know they got mathematical mumbo jumbo here. The conditional probability that a B occurs, given that A occurred, has already occurred, can be represented by probability B over A. Okay, we're not going to go into all that. Here's what we're going to do. We're going to simplify this. Example, we have a spinner. Here's a spinner. Naomi is playing a game with the spinner shown. What's the probability that the spinner lands on 7 given that Naomi has spun a number greater than 5? Okay, here's what we're going to do. Okay. Given is what we're looking at here, okay? What we're trying to do is we're going to put A and B together, okay, to come up with our numerator, and we're just going to use A as our denominator. You're like, wait, what did you just say? Okay. Everything that happens before the word given, okay, that is this probability B that they're talking about. Everything that happens after the word given, okay, is this A that's being spoken of. But here's how I want you to think of it. It's a simplified way of looking at it, okay? We're going to take the probability. We're going to put A and B together, okay, over the probability of A. Here's the way I like to look at it. We're going to take the probability of both events together, okay, over the probability of what we see after the word given. I'm going to demathetize this, okay? So what does this mean? Okay, what's the probability of both events? The probability the spinner lands on 7, given she spun a number greater than 5. So here's what I want to know, okay? Lands on 7, greater, given that we're greater than 5, over greater than 5. Put the two together on top, just what's after given on the bottom. So you're like, okay, so what does this mean though? If the number is greater than 5, okay, there's the numbers we're working with. So how many numbers are we working with? We're working with 3 that are greater than 5. How many of those numbers in that little piece of the pie there are 7? That's it, okay? You're reading through, this is going to be a more specific event. This is going to be more general. The bigger value is going to be on the bottom because we know with probability, my answer's got to be between 0 and 1, and 1/3 is between 0 and 1. It's always weird the first couple of questions, but then you start looking on where to get your numbers and your answers, and it does simplify quite a bit. So let's try, we're going back to the die. 6-sided die is rolled. Find the probability. Okay. A 4 is rolled. There's my magic word given. Okay. A 4 is rolled given that the roll is even. So what am I looking for? I want the probability of 4 and that it's an even, both parts, over the probability that it's even. Okay? When you roll a die, 1, 2, 3, 4, 5, 6. How many numbers are even? 2, 4, 6. 3 of them. So out of those 3 numbers that I underlined, 2, 4, and 6, how many of them are the number 4? One of them. And no, it does not mean that every answer we're going to get here is going to be 1/3. Just a coincidence. Okay? And so we keep doing this. Given splits our problem off. So what do we got? The probability of getting a 2, but has to be less than 6. And then less than 6. Okay, so if you're rolling a die, how many numbers are less than 6? Oops. 5 numbers are less than 6. Okay. How many numbers that are less than 6 are the number 2? It's got to be both. Well, one of them, there's only 1 2, 1/5. Okay. Is the number on top always going to be 1? Not necessarily. Okay. There are certain things we can make assumptions on, other things not so much. One more time. Okay. Probability of getting an even that is 3 or 4, because I take both the probabilities, put them together, over the probability that I'm going to get 3 or 4. Just the stuff after the given. So I'm like, okay, well, probability of getting 3 or 4, there's only 2 ways I can get the number 3 or 4. 3 or 4. Okay, what's the probability of me getting an even number if it's 3 or 4? Just 4. 3 is an odd number. It's not even. So that's when we're looking at conditional probability. Again, it's both together on the top and just what's after given on the bottom, because that way I'm always assured that the larger value is going to be in the denominator. Okay. Another way we can do this, if it's not just given to us verbally, is through what's called a contingency table. So we've got all these numbers. And so now I can go back and I can look at the conditionals. So let's see. Find the probability the student plays lacrosse. Oh, there's given. Given the student is a junior. Okay, let's write this out. Probability that they play lacrosse and are a junior, both go on top, over the probability that they're a junior. Okay, now we may not be given all the information every single time. We may have to do a little bit of work. So I look and I'm like, okay, people that play lacrosse. Ooh, like I have all the individual parts, but I don't have a total. Sometimes I'm going to have to do that part. So let's see here. So I got 17 and 20 and 34 and 17. So, oh, you can see that, 88. So I got 88 people that play lacrosse, but I also notice here that I'm going to need to know the number of juniors. So I'd add these up. Now I have some people that will just add all the columns and rows every time, and that's not a terrible thing to do, but if you can save yourself a little bit of time if you watch here. So, plays lacrosse and is a junior. Okay, that one I can take straight from the table. Juniors that play lacrosse. Total juniors. That's where I needed to make sure I did my addition. So one of my things I didn't need to do, but that's okay. 34 divided by 5, 44. We don't do math decimals, math enter, enter. 1 out of 16. Okay. So I do a little bit of math, but basically it's still just going to be, I'm plucking numbers from this chart instead of worrying about, trying to read everything in a sentence. Oh, the last page. Okay, another example with a table. Find the probability that a person can attend the wedding given that the person is in the bride's family. Okay, again, person can attend given that they're in the bride's family. So given that they can attend and are on the bride's side over just what's after given, probability of the bride's side. Your table. Can you get the information straight from the table, or are we going to have to mess with something? Can attend, okay. Bride side, 104 over the probability of being on the bride's side. Well, here's the bride's family, but I don't have a total. I know how many can attend and how many can't. I need the total. 4 divided by 136, math enter, enter, 13 out of 17. Okay? So just get into the hang of both events together over just what's after given. Keep it simple. Okay? Baseball. Find the probability a student plays baseball given the student is a senior. Probability plays baseball and senior. Putting the two together over what's after given, just senior. Same thing. Head to the chart. Baseball senior. 34. Straight up senior. Here's my seniors, but I don't have a total. And I want to take all seniors into account. So I put them in, calculator, math enter, get my probability. Now, those are pretty straightforward. You are going to get into some contingency tables at times that can throw you for loops because we might put some negatives in here. No. Oh, yeah. Last table. All right. Small businesses. We got how they're paying for what they do. So again, same concept. Okay. Find the given. Okay. Shopper uses a credit card given they're shopping at Jacob's Gas. Put the two underlined things together. Credit card Jacob's over just what's after given. Jacob's, let's see here. Credit card Jacob's, bang. 456. Over the possibility of Jacob's. Okay, I don't know that. So you're like, Hardy, is what you're basically telling me is the number in the denominator, most of the time you're going to have to just calculate it. Yeah, I'm saying that. Total them up. Rock and roll. Okay. And that's all I've really got to watch for. So shopper uses a debit card shopping at Pet Town. Okay. Probability debit, Pet Town, probability of Pet Town. Told you I was saving the easiest stuff for last. I wasn't kidding. Debit, Pet Town, 28 over all the Pet Town. 147. And get that reduced. Okay, very straightforward. Okay, last one. Shopping at TJ's given, forgot to do that before, paying cash. Okay, again, don't get sucked in because look, this time we switched it. We went from what type you were using and where you were shopping. Now it's where you're shopping and what you're using to pay for it. So probability of TJ's and cash over the probability of, not TJ's, after given, cash. So let's see, TJ's and cash, 102. Total cash, all right. So it's this whole row that we're gonna be adding. 595. I don't think that's gonna reduce. And I'd be wrong, okay. 6 out of 35. So again, I realize that you don't have, I mean, there's going to be a quiz. There is a quiz on this. Can it get you back one way or another? Maybe it gives you that last little boost into a grade so the final exam gives you an extra push. Maybe you're at, I don't know, maybe you're at 78 and this quiz on probability gets you up to 79.5 or 80, and then you can take the final and go from like a C to an A in like 3 days. That'd be cool. But again, practice is here. It's the end. Thank goodness. Okay. So you've got some extra normal probability there. The conditional probability, that's what we were doing today. You've got on page 24 with answers and stuff. You've had some review that's available on Delta Math. So you can do some of that before the quiz. But again, if some of you have been working on the final, that's something you need to get in here too. If you're on our normal schedule and you're looking at me doing this on a Wednesday, you've got a couple of days to get that final exam in, get that last push, and get that grade where you want to. Even though I'll be saying more things live in class, I just want to let some of you know that I've enjoyed the opportunity to try and help you out with some math here during this crazy time. I do wish I got to meet all of you more, like talking and stuff like that, because that's one of the things I enjoy about teaching is getting to know my students and their backgrounds and stuff like that. But please, once we get back into coming to school and stuff like that, just stop in and say hey, so I can put more than a couple of eyeballs with a face, and I can kind of get to know you a little bit that way. So we will see you next time. Have a super day.